Alright guys, so we will be doing the next tutorial video here. We will be working on our complex dimensional analysis sheet. So before we get started, I want you to get three things for me. Get your complex dimensional analysis sheet in front of you. Go back and find this table right here that has all your metric conversions. That's going to be a good reference to have. And then of course, pencil and calculator. I want you guys to be ready to go so you can kind of work along with me as we go through. Now, just a heads up, we will be working on numbers 2, 5, and 7. So after going through that whole key, I thought those would be the three that might be the best use of our time because it goes through the three different types of problems, I guess, that we might be doing. And I understand this is probably going to give some of you guys problems. Like I said in the lecture today, if you can do this kind of stuff and you kind of wrap your mind around the whole process, you'll be able to do anything else we do the rest of the year. It's not that you'll know how to do all those things, it's just that you'll be able to. All right? So without further ado, we're going to get started with number 2. So if you're looking at number 2, it says the mass of a bar of aluminum is measured 2 centimeters by 2 centimeters by 2 centimeters. Now, we got 2.0 centimeters by 2.0 centimeters by 5.0 centimeters. All right. So the volume of that there aluminum bar is 20 cubic centimeters. Now, one thing worth pointing out, because we are also in the midst of all this thinking about sig figs, is the fact that I know those zeros, which means I also know that 0 in the 20. So I'm going to change that scientific notation to reflect that. 2.0 times 10 to the 1 cubic centimeters. All right? So that is my volume. All right, so I had to get that first. So the question is, what is the mass of that bar of aluminum? All right? So in that table up there is some information that will help us actually make our conversion. So I'm showing 2 sig figs in my volume because that's going to be important for how many sig figs I want in my answer. All right? So my known quantity is 2 times 10 to the 1 cubic centimeters. So I'm going to go 2.0 times 10 to the 1 cubic centimeters over 1. All right? Now, in my table, what I'm going to do next, I'm going to go up and try to find some information up in this table that might help me convert my volume into mass. All right, so if you look on the table, you see that aluminum has a density of 2.70 grams per cubic centimeter. All right, now grams, of course, would be a unit of mass, so that is going to make that worthwhile for us. All right, so what I have to do then is decide what I'm doing with my units, right, in order to convert my answer into grams as opposed to just being in cubic centimeters. All right, so the rule is we talked about way back early is if I'm on the top here with cubic centimeters, that means my cubic centimeters needs to go on the bottom there. I can put grams on top, but I know that because I have a conversion of cubic centimeters to grams on this table. All right, so the next step then is what number accompanies these 2 units. All right, so aluminum says it's 2.70 grams per cubic centimeter. So the 2.70 accompanies my grams there, right? So it's 2.70 grams over 1 cubic centimeter. All right, now what I get to do is cancel my units. I get to cross off cubic centimeters there. That leaves me in just grams. Grams would be a mass. All right. So I plug that number into my calculator and I get the number 54, right? Now, I did ask you guys to put all of your answers in scientific notation. All right, so I'm going to go ahead and convert that to 5.4 times 10 to the 1 grams. And that would be my answer. All right. Quick erasing. So next step then will be to move on to number 5, right? So in this case, the speed limit on a certain highway is 70.0 kilometers per hour, right? And I want to convert that to centimeters per second. All right. So in this case, I'm going to have to convert 2 different units, like we practiced in the lecture today, okay? So I've got kilometers per hour. I want to convert that to centimeters per second. So I'm going to make 2 conversions, kilometers to centimeters and hours into seconds. That's the goal here, all right? So, like always, here's my known quantity, 70.0 kilometers over 1 hour, right? Now, I just need to decide, do I want to convert kilometers to centimeters first or hours to seconds? I think we'll go kilometers to seconds first, all right? So, kilometers on top, that means kilometers needs to go bottom, centimeters on top, right? My conversion, I use my handy dandy metric conversion table to figure this out. I have 1 times 10 to the 5th centimeters for 1 kilometer. At 5, remember, is the difference in magnitude between centi and kilo for prefixes. All right, so now I get to cross off my kilometers. So if I were to stop my calculation here, my units would be centimeters per hour. All right, I want to get that to centimeters per second. So I've got to do 1 more conversion here, straighten my line out. Okay, hours into seconds. Okay, now you guys should know already that go from seconds to hours, 60 seconds per minute times 60 minutes per hour, that's 3,600 seconds per hour. So the 3,600 accompanies the seconds for 1 hour. Okay, now a couple things with regard to sig figs here. So I've got 3 here. This number 3,600 seconds. Okay, it's exactly 3,600 seconds per hour, right? If we had exactly hours, so really our limiting number here is the measured, it would be 70.0 kilometers per hour, all right? So I'm going to not use just the 2 sig figs here. I'm going to use the 3 sig figs here because this is an exact conversion, okay? So side note there. So when I run my calculation, I go 70 times 1 times 10 to the 5th equals, divide that by 3,600, and I should get 1944.4 repeating, right? Now, I want to have 3 sig figs in my answer, so I'm going to go here to my 3rd digit. So there's 1, 2, 3, 4 comes after it, so that rounds down. So it's going to be 1,940. Right, which in scientific notation would be 1.94 times 10 to the 3rd centimeters per second. And I should, of course, cross those hours off over there, right? If you notice in my table, I've got centimeters on top, seconds on bottom that have not been canceled. So I know that's what my answer's units will be. So it's 1.94 times 10 to the 3rd centimeters per second. All right? And we'll do 1 more. Flip over to number 7. Okay, this one's going to be a little bit more complex. Okay, so it says gold has a density of 19.3 grams per cubic centimeter. What is the mass in kilograms of 1 cubic meter of gold? Okay. So I have the conversion of 19.3 grams per cubic centimeter. My known quantity is in 1 cubic meter. Okay, the known quantity is going to go to fraction over 1. Right. Now what I need to do, because my conversion factor is in grams per cubic centimeter, what I need to do then is convert my cubic meters into cubic centimeters. So m cubed cm. All right. Now, the problem before number 6, we actually already solved that problem, how many cubic centimeters in a cubic meter, all right? So do check your answer key on Edmodo to see how I got this number, but this is 1 times 10 to the 6th cubic centimeters per 1 meter, all right? So again, if we're just going centimeters to meters, it'd be 1 times 10 to the 2, but because it's 3-dimensional, we have to go 100 times 100 times 100, which is a million, all right? So that's where that number came from. All right, so now I can cross off my cubic meters, so I'm in cubic centimeters. Right? So my next step then, because I want to get my mass in kilograms. That's what I'm going to, right? So what I need to do now is convert my cubic centimeters into a mass measurement, which would be grams, kilograms, etc. So the conversion factor given to you in that problem is 19.3 grams per cubic centimeter. What I can do next is I'm going to convert cubic centimeters into grams. So cm cubed there, grams there. All right. So what I have in my conversion is 19.3 grams per 1 cubic centimeter. So the 19.3 accompanies the grams over 1 cubic centimeter. All right, so if I were to run my calculation now, I would get in mass, but my mass would be in grams. All right, it does ask for the mass in kilograms. I'm going to have to go one more step over and convert my grams into kilograms. So grams on the bottom, kilograms on the top. All right, and you use your metric conversion table again, okay, to determine that it's 1 times 10 to the 3rd grams per 1 kilogram.
Hi.
How's it going? I'm just finishing a tutorial video. Just a second. All right. So when you punch these numbers into your calculator, you should get 19,300 kilograms, or in scientific notation, 2 times 10 to the 4th kilograms.